Hello everyone and welcome to a little bit of a applet version of Fun Times and Statistics. This is from GeoGebra, which is a free geometry and algebra program that also does some statistics. I didn't want to scare you with the functions over here, so I kind of shrunk this over in the hope that these wouldn't terrify you, because in here is the actual normal distribution and how it's calculated and its equation, which is terrifying if you hated algebra, so just pretend that's not there. Um, GeoGebra is free, so if you're interested in maybe taking geometry or just playing around with it and doing some applets yourself, you can go ahead and download it if you'd like. We do not need it for this class, so don't feel like you need to. It's also a German company, so if you go play on their website, occasionally you run across things in German. This is someone else's applet. His name is Crayston? I can't say his name. And I will link to this below, that way he gets a proper credit. So I tried making one of these, but none of my colors turned out as nice as his, so I'm stealing. So what you're looking at here is two distributions. The one from the hypothesized mean, so that's appearing in red right here, which if you slide around this mean, you'll notice the red distribution moving, which is kind of nice. And the second being the distribution of truth, which we're marking with mu, because these are means we're dealing with. Now as you look at this, as I slide this one around, you'll notice some values changing. He's the blue distribution. So in particular on here, I have a couple different things. So alpha is set to be 7%. I'm going to actually bring that down to, well, I don't want to make it much lower. I'm going to bring it up to 5% because that's usually the standard that most statisticians use. So the idea is, remember, alpha is the probability that you make a type 1 error, and this is the idea that I reject a true null hypothesis. So over here, here's my true distribution, blue guy. And then over here, I have my red distribution. This is the one you got from doing your sample, or sorry, from your null hypothesis. So in green, I have the probability that you make a type 1 error. You rejected something that was actually, true. And so it's the part of beyond your sample that falls under the true distribution, the blue guy. So green stuff. Over here in blue, we have the type 2 error, or the probability that you incorrectly retained a false null hypothesis. So this sucker is false and you kept him anyway. So that's the stuff in the blue distribution that falls below the rejection region. So this was true. Sorry, this is false and you kept it anyway. So it's the stuff that falls below the rejection region. So if you're not in the rejection region, you're in an acceptance region. So you kept something that you shouldn't have. So now as you watch this, the effect size, if you've already watched the notes, is the distance between these two. And right now they're decently close together. So watch what happens if I move my truth distribution further away. My errors both get smaller. Well, alpha doesn't change because I have that fixed. But my power gets bigger, and here's the thing that stinks about this. My sample, my hypothesized value, is nowhere near this. So you're probably going to make the right decision, but it's also not going to be helpful. Crud. That's not really all that helpful. So I'm going to move this back over. The other thing is if you pick a better sample, oh no, I didn't want to mess with that yet. Sorry. Your hypothesized mean is going to be closer, and it has these are closer together, but notice how big your type 2 error probability gets, and your test gets weak. So as these interact with each other, it becomes very difficult to accept the fact that their likelihood of making a mistake is so high, it's scary. Now, it's not saying that you're going to make this mistake, it's just the likelihood of it happening increases. Just because it's probable only tells you it's possible, not that it's going to happen. Just like there's a probability, you may win the lottery. Doesn't mean it's going to happen. So if you want, go ahead and play with this a little bit. There's a couple other ones that I've found that are pretty interesting that work well too, but this is my favorite. And mess around with your hypothesized mean versus the real mean. The one I draw in the notes is actually a proportion, not a mean, so that's why I picked this one. Now, here's another thing you do. You can also increase alpha. Notice how more type 1 error means less type 2 error, and vice versa. Less type 1 error, more type 2 error. Darn! There's no making this happy, is there? Other than, oh god, I'm nowhere near the correct estimate. Sad but true. Okay. And if you're wondering where this line comes from, just as a quick reminder, this is the cutoff for 5% on alpha. So that's why that line moves around when I change alpha. Fun fact. Alrighty. That's all about I have for you for now for this video. I hope this helped you visualize what's going on as you move around values with the distribution. Sorry, with the distributions when investigating error.